Thanks for watching. And what is convolution and why is it important? Watch this video to find out. So what the convolution is, it's a way of multiplying two functions, but not in the algebraic sense, but in the cool differential equation sense. So given two functions f and g, f star g, what it is, it's the integral here from minus infinity to infinity of f of x minus y and then g of y dy. Or using the use of x minus y, this can also be written as integral from minus infinity to infinity of f of y, g of x minus y, and then dy. So two different ways which are, once again, equivalent using u sub, and there's a nice mnemonic to figure out if you're right or not. Because notice the sum of those two is always x. So x minus y plus y is x, and that's the same thing as y plus x minus y. I always get the order confused. And at this point, I highly invite you to check out the demo that is in the description, because what this is, it's kinda an average of f and g, but where f gets shifted to the right. So in the demo, there's this little rectangle, let's call it f of x, and then f of x minus y, it's the same thing, but shifted to the right, and somehow you're taking this with an average of this function g. So once again, it's kind of like a moving average where f goes to the right with the weight g. So once again, watch the demo to really have a nice visualization of this. Now, what we want to do is just a concrete example to see what it looks like concretely. So just as a concrete example, let's calculate f star g, where f of x is the exponential function e to the x, and g of x, it goes from 0 to 1 and back, so it's 1 if x is between 0 and 1, and 0 otherwise. So once again, what f looks like, it's this exponential function, and what g looks like, kind of between 0 and 1, it's just 1. So here it is 1, and outside it is 0. So that's g of x. And let's see what happens if we multiply the two, once again, in the convolution sense. So f star g, in this case of x, is the integral from minus infinity to infinity. So here, it's easier to use f of x minus y, g of y dy. But notice now, g is 0 if y is negative and if y is bigger than 1. So this just ends up being the integral from 0 to 1 of e of x minus y and then 1 dy. Because g is 1 inside that interval. Now, this e to the x doesn't depend on y, so it comes out. So you're left with e to the x, integral from 0 to 1, e to the minus y dy. So just to recap, you get e to the x times that integral, and then you can evaluate this. So I think you have minus e to the minus y from 0 to 1. So e to the x minus e to the minus 1 plus e to the 0. And so in the end, you get 1 minus 1 over e, if you wish, times e to the x. And you see, the whole point is, in the end, you do end up getting a function of x. because the y gets integrated out. And so once again, what is the interpretation? The interpretation is f star g is like a multiplication. Multiplication of f and g. Not like f of x times g of x, but sort of like f times g. And in fact, the cool thing is, it does become multiplication if you think about it in terms of Fourier transforms. Because in fact, if you define the Fourier transform of f as the integral of f of x, ei kappa x, dx, then we do have this very important fact that the Fourier transform of f star g is just the product of the Fourier transforms. So once again, f star g hat is the same thing as f hat times g hat. So the Fourier transform of this sort of multiplication actually becomes multiplication in this frequency space. And in fact, this will be the key that will help us solve the heat equation and that will help us get unstuck. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.